Our fragment component gets its dependency from the application context. This allows nice flexibility and reduces direct dependencies on a specific application class. We can't use our actual application subclass when testing our fragment in its own module. Our feature modules have no dependency on the app module, but even if we could, we don't want to. Using a custom test application allows us to create our own test version of the application component, swapping dependencies out as we please. This is really where the power of Dagger can be fully realized. We're going to start by creating a new module, and it's going to be called app, which of course we already have one with the same name. However, this is going to be a test-only module, so we're going to nest it under the testing subdirectory, and the create module dialog allows you to specify a subdirectory. This will allow us to keep the module name app. Since this is explicit, it should be easy to keep this from accidentally becoming a dependency in production code. In the build.gradle file for this new module, we'll use the Kotlin capped plugin, update the versions, and for dependencies, we're going to need the app component project, and we'll use that as an API dependency, as well as the app deps as an implementation dependency. We'll keep the app compat dependency, and yes, we should have moved this to our project level deps array, but we've gone this far, so I'm doubling down on this code debt. And then we'll also add the Dagger core and compiler dependencies. Lastly, change the Android X test group dependencies to be implementation and not Android test implementation. This library is going to be a dependency of other modules in their Android test build variants, and we're going to put the code in the main source directory here, so we need these Android X dependencies to be available to use in source/main. In the main source directory, create a new package called GitHub API. In here, we'll create something we're pretty familiar with at this point, a new class called fake GitHub API. This will implement GitHub API and have a mutable property that is the list of repos it should return. What this allows is tests can get a reference to this fake GitHub API and set this repo's value to whatever they want. We'll also make this an injectable singleton, which will make getting a reference to it in tests a bit easier. Now let's bind this to the GitHub API interface in Dagger. In this same package, create a new file called TestGitHub API module. This will be an interface with the module annotation, and we'll have a single method with the binds annotation called bind GitHub API. This has one argument, which is our fake GitHub API, and the return value is GitHub API. Again, this is telling Dagger that anytime someone attempts to inject GitHub API, give them this implementation, which is our fake one. And since our fake GitHub API is annotated with singleton, there will only ever be one instance, no matter how many times it's injected. Finally, we can create the test component. In the app package of this module, add a new file called TestApplicationComponent. Like our application component, this is a singleton, and it will have the component annotation. And then for the module's value in the component annotation, we want to declare TestGitHub API module. This interface will extend ApplicationComponent, which itself extends AppDeps. This is the recommended way to compose components for testing, extend existing ones. We'll create a component factory just like our application component, where we're binding the app context into the Dagger graph. As I mentioned before, we actually aren't injecting context anywhere, but let's keep it to reduce required updates in the future. Someone will always eventually need to inject the application context. Lastly, add a function on the component interface that returns fake GitHub API. This will allow tests to get a reference to this component and then retrieve the fake GitHub API instance from it. From there, those tests can update the repos that will be returned. We have one more step before we can actually write our first test, and that's creating the test application and runner, which we'll do in the next video.